Hello everybody, today I'm going to be talking about the trigonometric ratios. I hope you enjoy. What is trigonometry? Trigonometry is a study of triangles in mathematics. It is used almost everywhere to calculate distances, angles, as well as the areas of shapes that aren't triangles, such as hexagons and trapezoids, as there are triangles in almost everything. Today, we'll be talking about the trigonometric ratios such as sine, cosine, and tan, as well as the inverse of them and some triangle properties of the sine, cosine, and tangent. We will also be learning about 30, 60, 90 triangles and 45, 45, 90 triangles as they have special properties to them. Sine, cosine, and tangent. Say that you have an angle in a right triangle. That's not the right angle. And the length of the two legs. You should know that these multiple important ratios are used commonly in high school math. Sine. The sine of an angle is equal to the side length opposite to the angle divided by the side length of the hypotenuse of the triangle. It is most shown as sin on a calculator, and the formula of the sine of any given angle x is sine of x is equal to opposite over hypotenuse. So, for example, if we have x over here, that means the sine of x will equal to the opposite side. So this would be opposite side divided by the hypotenuse. So this would be O over H. And that means if we was to say O is equal to 2 and H is equal to 3, then the sine of x would equal to 0.66, as 2 divided by 3 is equal to 0.66. Repeating. The next ratio we're going to be talking about is cosine. The cosine of an angle equal to the side length of the adjacent angle divided by the side length of the hypotenuse of the triangle. It is most shown as cos on a calculator, and the formula of the cosine of any given angle x is a divided by h is equal to the cosine of x. So for this example, let's say the same angle x, but this time we're going to be labeling this as a, because this is adjacent to the angle of the x. And then we're going to be labeling this as h because the hypotenuse doesn't change. So that means the cosine of x would equal to a divided by h. And we can also say that if this is 3 and this is 5 and this is x, that means the cosine of x is equal to 0.8, because 3 divided by 5 is equal to 0.8. The next ratio we're going to be talking about is tan. Tan is the tangent of an angle is equal to the side length opposite to the angle divided by the side length of the adjacent to the angle. It is shown as tan on a calculator, and the formula of the tangent of any given angle x is tan of x is equal to opposite over adjacent. So say we have angle x, we'll be using the same angle, and we're going to be labeling this as O because this is the opposite, this is the adjacent because this is right next to the x, and this is hypotenuse. This time we're not going to be using hypotenuse, we're only going to be using opposite side length and the adjacent side length. And tan is equal to opposite over adjacent. So the tan of x would equal to this side length divided by this side length. So if this side length is equal to 3 and this side length is equal to 4, then the tan of x would equal to 0.75. Because 3 divided by 4 is equal to 0.75. The reciprocals of sine, cosine, and tangent. The reciprocals of sine, cosine, and tangent are called secant, cosecant, and cotangent, respectively. Cosecant. The cosecant of any angle is equal to the hypotenuse of the triangle divided by the side length of the opposite side to the angle. So that means it's the reciprocal of sine. So, for example, if we have x over here, the angle x, that means the cosecant of x would equal to h divided by o. So that would be over here. You would do o. This is equal to h. Sorry, this is hypotenuse, and this is equal to o. And that would mean that the cosecant of x would equal to h over o. So if this was equal to 5, this is equal to 3, then the cosecant of x would equal to 3 over 5. The next ratio we're going to be talking about is secant. The secant of any given angle is equal to the hypotenuse of the triangle divided by the adjacent side length to the angle. So that would mean that the reciprocal of cosine. So over here, we'll do h as our hypotenuse and a as our adjacent, and x will be over here because it is right next to the adjacent side. And here, secant is equal to h divided by a. That would mean that h divided by a would equal to h over a. And if h was 5 and a was 3, a was 4, to have it to be different, then that would mean that the secant of x would equal to 5 over 4. The next reciprocal we're going to be talking about is the reciprocal of tan, cotangent. The cotangent of any given angle is equal to the side length of the adjacent angle divided by the opposite angle of the angle. So that would mean cot of x would equal to a over o. And we know that tan is the reciprocal of cotangent, and cotangent is the reciprocal of tan. So over here, we would have angle x is equal to a, and this is equal to o. And the cotangent would be the opposite of tangent, which is equal to a over o. And that would equal to cotangent. So if this was 4 and this was 3, then that would mean we would have 4 over 3 as our cotangent of x. Some tricks that we can create with sine, cosine, and tangent. Because of how sine, cosine, and tangent all use the same lengths for every triangle, there are some tricks that you can use with sine, cos, and tan. So here's the first trick. Sine of x is divided by cos of x is equal to tan of x. And we know this because sine is equal to o over h divided by, and then cos, which is equal to a over h. And we can then flip it to get the reciprocal of cos to get h over a. That means o over h multiplied by h over a can cancel out these h's, and we can get o over a. And we already know that o over a is equal to tan. So therefore, sine of x divided by cos of x is equal to tan of x. The next trick we're going to be talking about is this triangle. So here we'll see that sine of c is equal to cos of a. We can know this because sine of c is equal to o over a. Alright? So that means that o over a for c is equal to ab over ac over here. But if we go over here, we can go to ab, and the cos of a is equal to ab over ac, because for a adjacent angle would equal to ab, and then the opposite angle would be equal to bc. Therefore, the opposite adjacents are switched. Therefore, sine of c is equal to cos of a. And over here we have a few equations. So the first equation is that sine of 45 is equal to cos of 45. and both of them are equal to the square root of 2 divided by 2. And these are some things we just want to remember. And then the sine of 60 is equal to the cos of 30. And the sine 90 is equal to 1. And sine 30 is equal to cos of 60. "45, 45, 90 triangles, and 30, 60, 90 triangles." A 45, 45, 90 triangle is a very common triangle that has the measures of two 45-degree angles and one right triangle. And the two legs of this right angle will always be equal. And the hypotenuse will always be equal to one of the legs multiplied to the square root of 2. So say we have a 45, 45, 90-degree angle. We know it because both of these sides are the same. And these have an angle measure of 45, 45, and a right angle. That means that x would be equal to both legs. That means no matter what this is, even if it is 3 or 3 million, x would equal to the other side. And the hypotenuse will always equal to x multiplied by the square root of 2. So if you have 3 as your x, then the hypotenuse will equal to the square root of 2 multiplied by 3, like this. The next triangle we're going to be talking about is the 30, 60, 90 triangle. The 30, 60, 90 triangle is also a very common triangle. It has the measures 30 degrees, 60 degrees, and a right triangle, and a right angle. In this right triangle, the hypotenuse will always be 2 times as large as the shortest leg. So say if you have the shortest leg as 2, then that means the hypotenuse will always be 4. And the longest leg would always equal to the shortest leg multiplied by the square root of 3. So in this case, the longest leg will equal to 2 multiplied by the square root of 3. Goodbye. Like and subscribe too.